Alright, Wiki's book, Circuit Theory, all chapters. Alright, mutual inductance, magnetic fields. Inductors store energy in the form of a magnetic field. The magnetic field for the inductor actually extends outside of the inductor. The can affect with another inductor close by. Image above shows the magnetic field. Red lines and extended around the inductor. Mutual inductance. Accidentally peripheral with the two inductors close together. They actually transfer volts of current from the one inductor to another. Property with the mutual inductance. A device that utilizes the mutual inductance, alter the voltage current output with the call of the transfer of the inductor, create the magnetic field with the call of the primary coil, with the inductor picks up with the magnetic field with the call of the secondary coil, transfer of the design with a greater mutual inductance of both coils, and the same calculations. In calculation inductance, we know have the material form of the path of the magnetic flux, air core. Coils have low inductance costs. Core of irons and other magnetic field materials are better conductor with a magnetic flux. The voltage appear with the secondary coil with the change of the shared magnetic field each time of the current through the primary change of the transformer. AC power since the voltage current changes continuously. You have an ideal transformer, so the core in the middle and the fusers, the commutators on the left. You have a UP and U, so yes, which is inductancy, power, and primary and secondary. Modern inductors, the coil turns of the number N to the base of 1 conducts current with the magnetic field B on the coil changes B, which generates the inductive voltage of turn of the number turns of coil number 1 and number 2 are shown. Thus, the device is capable of increasing the degree of the conducting voltage change with the turn of the ratio of the coils. Therefore, the output voltage can be increased to step up with the increasing the number of turns of the numbers. Turns of the greater the number of primary, decreasing step down, increasing number of turns of the coil less than the number of primary, and the buffer setting the number of turns of the secondary equal to the number of primary. Increase step up, increase the number of the turns of the coil secondary, and greater than the number of primary. Decrease step down, decreasing number of turns of the coil secondary less than the number of primary. Buffer setting the number of turns of the number of secondary is equal to the number of primary. Following photos show that simple example of the construction of inductors transformers. Upright tortoreal mathematic terms, the donut shape. The very efficient contains magnetic flux, although less power. The signal is lost, heating up the core. Step up and step down. The term step up and step down you use to compare the secondary output voltage to the voltage supplied to the primary. Many transformers specifically designed to operate exclusively step up, step down with the ideal transformer can simply with a turn around. So we find that actual transformers perform best certain range of voltage current. For example, the power transformer may even step down with the AC about 120 volts or 24 volts, a home heating control system, etc. Output current is higher than primary current. Example, the setup of the transformer is made heavier gauge of the wire into the secondary wire. The transformer to deal with a high voltage, special attention paid to insulation winding of the deal with 1,000 volts must be resisting arc and other problems we do not see at home. Finally, some of the transformers electrical equipment design last known as impedance matching rather than specific input and output voltage function explained literature covering audio and radio topics. Further reading sheet of the electronics and transformer distinction has not been written yet. State variable approach. New techniques are needed to solve second order and higher circuit symbolic solutions complicated than merely comparing answers and exercise the analytical solutions. Techniques have the most fragmented relation between constrained and initial condition circuit layouts are being complicated. To change the strategy of the need of the circuit analysis is going to move beyond the ideal. Consider more completed circuits and understanding limitation approximation sort of modeling software solution. State variable analysis exercise creating symbolic solution can be simplified and eliminating terms that does not have some significant impact on the output. State space is approach to circuit theory with a symbolic analytical approach to circuit analysis. The state variable model will involve the describing the circuit with the matrix form, solving them numerically using tools like series expansion, the Simpson's rule, and the Cramer's rule with the original starting point of the MATLAB state. State means the condition status for the energy storage elements of the circuit. The sense of the position does not change ideally, does not store energy. They do not change the circuit state. The state is the snapshot of the time of the currents and voltages of the greater the state space. Analysis created the notation to describe all possible states. State variable notation used to describe all the states should be as simple as possible. Instead of trying to find a complex high-order differential equation, go back to the Kirchhoff analysis. Just write the terminal equation. State variable, the voltage across the capacity of the current through the inductor. This means the perfectly result as if the current circuit current sets are closely collapsed by a single resistor. End up with the inductor parallel to the capacitor rather than using a symbol, the voltage or amps, to represent these unknowns. They are both called Kirchhoff equations instead of the node or loop equations. Terminal equations are substituted with the Kirchhoff equation, the remaining of resistor current voltage shared with the inductor capacitors. State and space model. State and space model describes the input step-up function in initial conditions, output y, and A, B, C, D, A, B, C, C, D. Transfer function combines as control system class teaches us how to build block diagrams, desired transfer function integrals, remember the accumulate history of the past states, derivative predict future state as in both indicate in addition with the current state with a separately scale with the A represent with the feedback of the D, the represent the feed forward. This is a lot to learn. Do not try to figure out with the negative sign with the period with the denominator where the addition term came from. How does the above with the predict the volts of the currents of the circuit. Let's start with the defining of the terms of some of the examples. A is the square matrix of the circuit components of the Kirchhoff equation. B with the column matrix of the vertex between represented with the source of the impacts of the circuit. C is the row of the matrix 4 vector representing how the output is calculated, computed if the volt could be voltage or current. D is the single number to indicate the multiplier source that is usually 0 unless the source is directly connected to the output of the resistors. A and B describe the circuit, the general, the X of the column matrix vector representing all unknown voltage and the current through X is the column matrix vector of square root the representing voltage times X minus the B times the U. This point is known with the representative column function time of the output of the derived with the X of the original step function, the U with the using C and D. MATLAB implementation. This would be not to be step forward without tools of the MATLAB, but these are relevant MATLAB control system functions. Command step A, B, C, D. Assume the initial conditions 0. Initial A, B, C, and D. X is with a variable with a time 0. The steps up that takes the actual initial conditions. X is 0 with addition with a stimulus block called the state space. They're usually in the same way. Video introduction, 41-minute introduction on Diligent Corp, and you can find that on a YouTube 5-minute application surfing of the YouTube. The further reading control system space equations, MATLAB links, syncytial sources. Or syncytial sources, steady state. With a steady state means that they're not dealing with a turning on off, turning off circuit with a section, assuming that for the circuit to turn vary with the long term would go with the beginning, having a pattern, computating the pattern would look like a complex frequency section model during with the on and off circuits with exponential. Syncytial circuits we analyzed previously with the bend DC with the constant voltage of the current supplied with the circuit with the following chapter to discuss the topic alternating current utilizing syncytial force functions to simulate the circuit. Syncytial forcing functions, let's consider AC forcing function voltage times of the M is called the magnitude times the width of the time over the offset parameter or phase. In this equation, M is called the magnitude, acts like the scaling factor, allowing the peaks of the syncytial to be higher than lower than plus or minus 1. The term of the W is known as the radial frequency of the term offset parameter known as phase. The syncytial source of the current source must often have the voltage for the other terms of the two. There are a few other terms that are going to be used in any of the following sections. We'll introduce them here. Period is a syncytial function amount of time and cycle the syncytial takes to make a complete wave. This period syncytial allows you to denote the capital T. This is not confused with the lowercase t, which is even an independent variable of time. Frequency with the reciprocal over the period, the number of times per second syncytial completes the entire frequency. The frequency with the Hertz relation to the frequency in the period is frequency over the 1 times the time. Syncytial wave, the very most commonly used expressive frequency, radio frequency. Radio frequency value with the expressed with the radians per second instead of the Hertz. Radian frequency is denoted as variable width. Variable wave with the relation for the frequency. Radian frequency is width the wave is equal to 2 times pi times the frequency. Phase is a quantity expressed with the radians over the time shift of the syncytial fish with the parameter times 2 times the parameter is equal to plus 2 times pi is moved with the forward 1 period. Looks exactly the same with the important factor. Remember that sin is equal to 2 sin times pi to the over 2 times the sin Sin times pi over 2 minus t is equal to cosine of 10, or the sin of t is equal to cosine times t minus the square root of t. So it's backwards. First, often express the differential variables with a parameter, and 0, and all this symbol 0 to prevent confusion. Leading lag. The circuit element may have both the voltage across the terminal with the current flow for the two flowing through the two current voltages of the sinusoidal sinusoidal with the other most of the sinusoidal. Remember, the voltage derivative of the current with the derivative of the sinusoidal always sinusoidal. The half of the sinusoidal voltage current may differ with the quality with the magnitude and phase. The current has lower phase angle with the voltage current with the said to the lag of the voltage with the current with a high phase angle with the voltage is said to the lead of the voltage. The many circles classified with the examiners with the lag and lead ideas. Sinusoidal response reactive components of the capacitor and inductors are going to take an energy of the circuit like the resistor, pump some of the back into the circuit like a source. Result of the initially massive, but after a while the 5 constants of the circuit started behaving the pattern of the capacitor and inductors, give it a rhythm and reflect with the driving source. The source is sinusoidal current voltage of the sinusoidal. This is called a particular steady state response in tremolo. What happens initially, they happen to the capacitor initially charge that happens the source of the switch in and out of the circuits of the which of the energy imbalance. Voltage current source may be charged with initial energy with the capacitor with the derivative of the voltage current. The inductor might instantaneously switch polarity. Lots of things happen. We're going to save this later. Here we deal with steady state and particular response. First, sinusoidal conventions. The purpose of this book, we generally use the cosine function that oppose with the sin functions. Absolutely need to use the cosine width over the time, so it equals sin times the pi over 2 times the so the width times the time. The extra sum of the function phase function this way, but they do not have the orange per se, and simple with the convention of the wiki book change these things completely simply. We could easily choose to use all sin functions, but further down the road, and more other convenient to use cosine functions instead of the default. Sinusoidal sources. There are two primary sinusoidal sources: outlets and oscillators. Oscillators are typical crystals of the electrical vibrate and are found in a device that communicates display video with the touch of the TV, communicator, cell phones, radios. Electrical energy or text working in the area typically include function generated to produce the oscillations and frequency shapes that are not sinusoidal. RMS means root mean square, means it measures the amplitude of the cross compared with the DC magnitude of the terminal power and strength of the motor, brightness and light. The trouble there is the shovel the type of the AC amplitude, the peak to peak, and average and root mean square. The outlets called for AC alternating current wall outlet sinusoidal voltage source of the range from 100 root mean square voltage 50 Hz to 240 root mean square voltage 60 Hz worldwide. Root mean squared rather than peak makes some more sense of mathematically described the magnitude. Several reasons, historical reasons related to the competition between the Edison DC power and Tesla sinusoidal or AC power effort with compared with the AC wall outlets. DC car batteries 100 root mean square voltage approximately 100 DC volts. Every sinusoidal 0 meter movements for the physical needle move. The measurement of devices designed for the both DC and root mean squared AC. Root mean squared typical average of the power of the root mean squared is equal to the square root of 1 over times the t with the base of 2 minus t by the base of 1 with a limited series with t to 1 and power times t the squared times d the second. Electrical power delivery is a complicated subject that will not be covered with this course for the time of the define of the terms of design of the device. The power can understand it clearly when it comes out of the wall outlets. Phase representation, phase variable. The variable to define with the same with the difference performed with the variable unknown with the sort of within or in between with all this point with the concept function with the number of the variable function variables with the time the need of the review, see with the stream of the professional dialogue, known with the describe of the function, the unknown with the computer based upon the knowns and all the functions of the VT with the simple function assigned with the function of the M, W, and the parameters of the time. The typical time that is not ever solved for. Time remains unknown. Furthermore, all of the power and voltage current into the equation time of this time is not solved because the time is everywhere. But they eliminated the equation with the integral the derivative into the algebra answer comparatively with the numeric before time is added back in. At last one with the time in the back end of the voltage current power with the final solution function of the time. Most of the math of the course of these steps of the describe the unknown time generators describe all equation chains that know the phase of the eliminator derivative integrals of the equation. So the numerically symbolically over unknown to the phase domain transfer unknown back to the time domain. Passive circuit output similar to input Over the linear circuit with the sinusoidal output with the circuit will be sinusoidal, specifically the voltage sinusoidal, such as the current through the linear circuit with the sinusoidal, along with the magnitude phase of the different quantities. Know that both the voltage and the current sinusoidal have the same radio frequency, the different magnitude with a different phase angle. With the passive circuit elements cannot change with the frequency sinusoidal for the other magnitude of the phase. They do not need to write the wave in every equation that does not change with it for a matter of the do not write out with a cosine function. But if it never changes either, the answer for these equations we do not write these things every time. Instead, the engineers have produced a shorthand way of writing these functions called phasors. Phasor transformation. Phasors are a type of transform that transform circuit math and time to disappear with the imagined going place from time that doesn't exist. We know that every function can be written with a series of sin wave of the various frequencies with the magnitude added together. Look under the Fourier transformation animation. The entire with the construction of the sin wave with the sin wave repeat that does not make with a particular time. Look at all the matters of the look relative to the beginning of the period. However, the higher one-sided wave looked at the repeating nature of the wave that's stripped away with the left of the phasor. Since the time it made a circle with considered just one circle that cannot move with the world, with the time does not exist as circles are things instead of the instead of the word world uses the word domain and plane with the two dimensions. The main math of phase domain is also almost the same in the DC circuit analysis, handy because of the means have it does not solve with the differential equations you give it the solve of the circuit. The different inductors capacitors have the impact of the needs accounted for. The transformer phasor plane and domain with the transfer back with the time based for the Euler's equation region for the study with the measuring numbers of the past math classes. Euler's equation, cosine sin, and the Euler's formula obvious for the mathematics, physical, engineering physicist Richard Feynman called the equation R of Joule one of the most remarkable, almost outstanding formulas in all mathematics. More general version, Euler's equation, and the equation all have the sinusoidal complex exponential function, the analytical function representing voltage, current, power, given in all terms of radio frequency, phase angle, with the area with the c, the magnitude, with the angle of the phase domain, and the point having the real x and y coordinates of the complex domain plane. Generally, the phase magnitude could be the voltage, current, power can be written as phase. The magnitude is equal to x plus the j, the junction of y rectangular coordinates, and the x is equal to the m magnitude, voltage, and an angle of the phase polar coordinates. When graphing points x and y complex plane with the drawn into the shown with the x, y, and the magnitude and the phase, using the fact of the angle of the original complex of the x and y and the function. And using a Pythagorean theorem, we can find the magnitude, the distance of the origin of the x and y as magnitude or c origin of the magnitude is equal to the square root of x squared plus y squared. Phasor symbols. Suppose the time domain voltage time is equal to the magnitude voltage of the times the energy of the amps times the wave time times the phase angle of the phase domain of the voltage expressed as voltage equal to magnitude voltage the phase angle. Radio velocity disappear with now the function of the derivative of the integral operator reappear with the time expression of no, not a vector. Some argue that phasor vectors are be careful of the phase of the diagram is not rich in vector space of the field of the space of the inspiration and math of the concept of the phase of the so the number of the possible the imaginary number of the phase of the diagram and explain with the imaginary numbers is physically divided, multiply the data, and subtract with the one dimension thing. The math of phasors is exactly the same with the ordinary except with the imaginary number the vectors demand with the new mathematical operations show the dot product, cross product. For example, the north divided by the east and subtract with the west. For more detail with the Wikipedia phasors, read with the conversionally with the Quora. What is the difference between bandwidth phasor diagram and the vector diagram? The dot produced over the lines of shadow of one vector with another cross product vectors, but combined vectors. A third vector perpendicular to both of these products do not phase. It can be viewed with the phase AC current with a motor starter with the stator or rotor, with the consequent of the creating of the torque. All these especially vector products. Cosine convention. Important to remember the trigonometry function of the phase for the mapping to it. This is the phase for the information magnitude of the phasing of the most is impossible to know whether given the phase for the maps the sin function, cosine function instead of the convention. The Wikibook's most electrical text documentation map of the cosine function. In this book, all phases correspond with the cosine function, not the sin function. If you with the answer the convert then subtract 90 degrees, and similar requires the source to be sin form, starting with the cosine, convert the sin by adding a 90 degrees. Your phasor concept with respect with the phasor, the main concept with the name of the inductor with the capacitor can be coupled with the derivative operator transform will appear with an imaginary resistance called reactance. The combination of resistance and reactance over the called impedance. Impedance can be treated algebraically as a phasor, although technically is not. With the power concept of the real active such as real reactive, the impairment with the power factors appear in phasor domain. Numeric math can be done with a phasor domain. Symbol can be manipulated with a phasor domain. Phasor math. Phasor math is done in measuring numbers as reviewed below. The phasor A can be multiplied by phasor B. Phase angles, because of the time of the domain, they are exponentaneous things multiplied together. Again, phase angles are treated like exponents, so they subtract. Magnitude angle forms of phasors can be used with addition, subtraction for the need of the converting phasors into rectangular notation. However, converting the polar magnitude angle with a rectangular formation real imaginary. Once the regular rectangular form, real parts of the gets added and subtracted, measuring parts added and subtracted. Here's how to convert the rectangular for the polar form. Phasors addition, one polar phase form conversion back into the time domain easy. Function transformation, deform derivation. GT represents the voltage current power. The voltage current power starting point, Euler's equation, law of the exponents, real number that can be moved inside, and the phase of the definition of the phase expression substitution. And reducible real number moved inside where G is equal to the phase of the expression substituting. What happens with the E to G junction with time long answer hangs around until the transfer back in the time domain because of the exponent. All phasors math algebraically associated with the exponent final phase of the multiplied into the real part of the expression with the time domain solution. In all cases, remember that parameters of the phase. The angle, the phase is constant no value in most cases. The phasor of the complex number, the most for the compilation number, the transform associated with the derivatives of the phasor calculus. Transformer calculation operator phasors. The sinusoidal representative of the differential equation become an algebra result with a function of the complex exponential eugenic function operation. This only complex amplitude chain with the derivative equation, taking the real parts of both sides of the above of the equation. Familiar results for the time of the derivative of the sinusoidal become with the transfer of the phasor domain algebra, the square root with a negative 1 or imaginary number. Similarly, for the time and the integral train with the phasor with the limited voltage time, the distance of the resultant and over the voltage over the junction of the wave of the integration constant will have to deal with the transient black with the time domain with the disappear with the true voltage current and power. The question is, why does it work? Where is the fool? Where's the proof? Let's do it 3 times once. The resistor and the inductor of the capacitor symbol the current and the voltage going through the terminals. Resistor terminal equation, terminal relation substitute example function, the Euler version, terminal relationship, laws of exponents. Do the same thing on both sides of the equation, time domain, and phasor expression. Voltage current in the phase form and the substitute with the migrated to the equation in the phasor domain. Induction terminal equation, terminal relation to substitution, generic sides will take the derivative of substitution from the equation, Euler's equation, laws of the exponents, real numbers that can be moved inside, substitute above the cancel out. The the energy junction, the number of electron junction width terms on both sides of the finite phasor equation transforming into phase domain. Conclusion: important the voltage, the current phasor form, it replaces distance over the distance time with junction width, translating the equation to phase domain. Capacitor terminal equation show the capacitor basically in the same form of the voltage amp switch sides. The capacitor is substituted for inductance. Inductor term relationship substitute with the generic side will take the derivative trig substitution from the Euclid's equation law of the exponents real numbers moved inside substitute above the equation substitute above the cancel out of the energy Number of electrons junction wave term with the both side with different definition favor the equation transform the phasor domain. Conclusion and put the voltage current phasor in the form distance replace the distance over the distance time of the joules junction wave. Translate the equation of the phasor domain. Summary of all the terminal relations to the number of electrons junction wave terms is cancelled. Interesting about the path of the inquiry, the logic thought with a new concept that merge devices, voltage over the amp over the voltage, resistance 1 over the resistance of the capacitor, 1 over the junction with the capacitor, junction with capacitor, with the inductor, junction with the inductance, 1 over the junction with the inductance. JW determine the cancel of the derivative of the terminal relay for the derivative of the terms associated with the capacitor and the inductors themselves. And if it is not, the sort of the derivative is applied with the sort of the independent of the derivative or originations of the capacitor and inductors have left with each of the transforms over the deriving force over the output over the input ratio with the one side with the equal sign. Consider separately with the other side with the equal sign with a function. These functions are we have the name transfer function, analyze voltage current ratios in terms of RLs and C. Any sweep of the width wave with the varying driving source of frequency constant sweep of the variety of the inductor waves we can analyze with circuit response. Note for these transfers their entire cross section will come up with a mechanical energy circuit system that can also be some of the similar driving over the bumps, the surge of the spike with the driving over a curve with the circuit, and when the mechanical energy instead of vibration of the deal is sensational driving function of the dealing with a three-dimensional object rather than one-dimensional object like we are in course. Phasor domain and time domain. Getting back to the time domains is just as simple as after working these equation phases domain, finding voltage amp. The goals of converting volt and amps of the phase solution. We should now convert the two forms in solution. If the integral involved with the phasor math comes to need to add of the time domain solution of the time of the constant calculated with the initial condition solution can be involved with the differential equation time to compute with the immediately. Otherwise, some solution treated a particular solution time can solve with the computed with the homogeneous solution magnitude is found with some of the phasors example of more detail. Where does not come with another way to think of the short circuit with the inductive with the capacitor complex resistance of the idea with the impedance equal to the resistance time of the joule of time the reactance, where symbolically impedance with the equal to the resistance time of the joule times A for the derivative of the attached for the inductance capacity rather than the terminal equation. We have the time of the spreads for the math and solve the circuit of the smaller piece with the more easily checked. But it makes symbolic solutions more complex than causes numeric solution error with the accumulated because of the intermediate calculations. Phasors concept found everywhere. Some of the day will be necessary to study these and involved with the microwave projects, the move and some of the antenna projects that involve the loading coil. So the list is huge. The goal is to avoid concept of conduction, reactive, and impedance substance, susceptance, and admittance to avoid the confusion of the relating the concept of the triangle, the compare the phasor map of the calculus and the Laplace transformation. Show the capacity, polar notation, exponential notation, rectangular notation, time notation, forward notation, different ways, the same as exact thing. Phasor symbols writing in a board on the paper Z with an arrow on top of it denotes the phasor of the expected variation book on outline for large block letters with the wiki books, a bar notation of the Wikipedia, bad save vectors, arrow notation, some of the textbooks and some of the textbooks different equations. Phase generate a particular solution. Phasors can be replaced with the calculus, replaced with the Laplace transform, where they can replace trig with there. But there's one thing you can do with the initial condition, integral constant, with during problems with both phase and Laplace with the phase calculus, the difference for the entering going to the integration constant. The different equations solve with the cars of these three steps of a particular solution, particular driving function, particular voltage current source. Finding homogeneous solution the same, no matter what the driving function of the solution, when it explores how the input, the initial energy imbalance of the circuit is balanced, determine the coefficient concept of the integration with the initial conditions. Phasors do not generate integration concept of the constant integration concept that does not appear in the phase solutions but will appear with the Laplace and calculus alternative phasor solutions. It is full differential equation that is going to be solved with the absolutely necessary to see with the phasor fail to create with the symbol with the unknown integration concept of the calculated with the third step. Phasor technique used to find with the AC solution integration concept of the documentation initial DC bias energy difference in the circuit with these concepts required for the first finding of the homogeneous solution which deal with the fact that the capacitors may or may not be charged in the circuit as it is first turned on. Phasers do not completely replace the step of the differential equation. Phasers just play with the first step and find with a particular solution. Differential equation review. The goal is to solve the ordinary differential equations ODE with the first and second order with both phases of the calculus Laplace and transformers. The phasor solution can be compared with the content of the prerequisite co-requisite math courses. The goal is to do with these problems with American symbolic tools with the math lab, with the MUPAB, with the mathematical Wolfram Alpha, which already have the differential equations core for the quick review. Most important to understand the nature of the function of the trig and calculus Laplace transformation phasors are all associated with the function of the algebra. To do not understand what the difference between algebra and the function may be a student professor dialogue will help. We'll stare at these equations with a terminal definition, loops and function. Each is similarly algebraic function will transform the equation of the transform of the function of these equations. However, the operators that appears in these equations include the plus and minus and multiplication and division, as in d and over d times t. First table of focus and transfer of the operator. Second focus of the transform of the function of these themselves. Real power Laplace transform of the eliminates the integral the differential operator of the function themselves can be the transform of the unknown found in the algebra of the functions can be transformed back into the time domain functions. Here are some of the property theorems that need to be transferred for typical Sinusoidal voltage power circuits in class. Time scaling, time shifting, linearity, differential, and integration. Laplace function, exponential decay, exponential approach, sin, cosine, exponential decay, sin wave, exponential decay, cosine wave. Phase circuit analysis, phasor analysis of the mathematical representation, individual circuit element converted with a phasor notation. The circuit can be the solved with a phasor of the resistant impedance admittance with a phasor notation, resistant impedance with inductance lumped together in a single term called impedance, with the phasor for the impedance with the Z, and inverse impedance with the admittance with the denoted as V, V is the voltage, I is the current, so the impedance is equal to 1 over the voltage, and voltage is equal to the impedance times the current, or equal to the current over the voltage. It's important to know that the Ohm's law holds true for even then when the switch of the time of the main phase to the main of the main, all the more amazing the fact of the new term of the impedance is no longer property of only on resistors, but now is encompassing loaded elements of the circuit capacitor inductors too. Impedance is measured with the units of Ohm, but the admittance of the conductance of the DC counterpart measured on units of the Siemens linked together closer to the equation. Voltage is equal to the impedance times the amps. We bring this to polar notation found as magnitude of the voltage is equal to the phase angle of the voltage of the maximum impedance of the maximum A times the maximum amperage. It is the less than the phase impedance plus the phase angle. This phase amps. Important because it is not only the magnitude of the current related to each other, but also with the phase angle with respect to the wave that is related with the different circuit elements of the different effects of the magnitude of the phase angle with the voltage given a certain current will explore the relations between. Below, resistors generally affect the phase of the voltage of the current magnitude, therefore impedance of the resistor resistance of the impedance of the resistor is 0. The difference for the current voltage will not change. It's important to remember to analyze capacitor of the capacitance phasors. Impedance for the capacitor will be equal to -1 pi over 2, that's right, the time term of the degree, but as impedance for the capacity with less than -90 degrees. We consider this now being axiomatic. We'll consider the fact of the phase of the graph of the imaginary plane. We can easily say with the phasing with a -pi over 2 point directs downward with the line with a negative imaginary axis, because they can come with an important conclusion. Impedance for the capacity of the imaginary in sense, since the angle over the directly along with the imaginary axis. This is not a real part of the phasor, but off of the known part with the impedance for the capacity with the no resistance, because of the resistance value is stated above. The reaction of the capacitance of the capacitance of the AC circuit with the angular velocity of the width of the wave has reactance over the reactance is equal to 1 over the wave over the capacitance less than 90 degrees, -90 degrees. Reaction with the impedance over the AC circuit with the angular velocity of the wave. The inductors have the phase value. The impedance of the inductor is less than 2 over pi with the inductance over the inductor over the right with its degrees. Impedance over the inductance is less than 90 degrees. Like capacitor, we see the phase indicator shows the value of the impedance located directly over the imaginary axis. However, the phase value of the inductancy with exactly opposite of the direction capacity phasor. For the notice of that here the inductor is no resistance because of the resistant real value. The inductors have the imaginary value. Reactance AC circuit show the source of the angular velocity of the wave. The inductors over the inductance L. Impedance connected in series. If there's several impedance connected in series, it's equivalent impedance with the simple sum of the impedance is The logarithm of the series is the impedance is equal to the impedance of the series. Notice that there's either have the differential of the formula combining capacitor, the resistor, inductors in series. There's all the resistors, capacitors, and inductors all can be mixed without carrying type of the element. They are the variable because when they combine with a different element, a single impedance value with output with a different value of the inductance, capacity, and resistance. Keep in mind, however, the phase of the can be inverted with the rectangular coordinate to begin added together. If you know the formula, you can write a smaller computer program, small application problem, programmable computer calculated to make the conversions for you. Impedance and parallel. Impedance connected with the parallel combined with slightly more complicated impedance parallel is equal to the amperes times the amperes and with the total number of impedance with the connected parallel of the impedance with the multiplied by the polar representation converted to rectangular coordinates. The summation of the calculation could be a little bit more time consuming with the following. With the alternate having to deal with the time of the separately can you with each of this much easier. This is impedance parallel. Step of the solving the circuit and phasor. There are 5 fewer general types of steps of solving the circuit in favor of the converter elements of the Fourier phasor notation. Combine impedance if possible. Combine sources if possible. Use Ohm laws, Kirchhoff laws, and solve the circuit to convert back to the time domain representation. Unfortunately, phasors can only be used as sensible input functions and come below with the phase of the explain with the DC circuit with the MB and employ phasors with the input function that sensible periodic function that's handled with the curve. We'll look at more general methods of the chapter in later chapters. Network function, the network function phase of the H of the ratio of the circuit of the input to its output with the important become with the solve the circuit with the down with the network function that we can find with the response with any sensible input. Simple multiply the network in function of the time to domain analysis we have solved the circuit with the new input will have the very time consuming. Indeed, the network function is defined as the following: as input is to its output is of the phasor representation circuit output over the representation circuit input, the time domain to define the output with the need with the input with the response of the network function because of the simple matter of the multiplying the input phase of the network function to get the output phase of the method with the converted with the entire circuit because of the simple function chain with the magnitude, phase, angle, gain. Gain is the amount of the magnitude sinusoidal amplifier that actuated with the circuit with the gain with the imputed with the network function. Gain is equal to the phase ratio of the circuit input over the circuit input. Circuit output over circuit input wave, with the bars around with the magnitude phase of the absolute value. There are only there are other math texts with the gain of the measure of the magnitude charge with the current or voltage. Most frequently, however, they describe the phase, describe the voltage. Phase shift is a function amount with the phase change with between the input and output signals. It can be calculated with the network function such as the phase shift series, phasor theorem, circuit theorem. The phasors were absolutely usually useless if they did not make an analyst circuit easier. Luckily, old circuit analysis tools work with values of phasor domains. This quickly little list of tools have already discussed the continuing of the work of the Ohm's law, Kirchhoff laws, superimposition, Thievery and Norton source maximum power transfer. Page describes how to use some of the tools described in the DC circuit, the AC circuit using phasors. Alright, Ohm's law was already seen with the bend with the following equation: phasor domain, voltage is equal to impedance of the amps, separating out the magnitude of voltage, the angle of the parameter of voltage is equal to magnitude is the impedance times the magnitude of amps of the angle of the angle of the times the angle of the angle of the impedance plus the angle of amps. We consider the magnitude relation with the current of the impedance of voltage phasors. Kirchhoff law still holds true with the phasor, but without alteration. Kirchhoff's current law states that the amount of the current entering a particular node must equal the amount of the current leaving the node. Notice for the CCL never specify the current must be the type of the current works. RCL holds true. The KCL phasors, Kirchhoff voltage law, some of the voltage of the closed loop must always equal zero. The form of the voltage function, forcing a function, and never consider the current voltage. Kirchhoff voltage law holds true with the input function. Superposition may be applied with the circuit source with the same frequency. Superposition may be used as other only possible to solve the circuit source with a different frequency. The important to remember the impedance of the value of the circuit are based on frequency derivative of the reactive elements react with the frequency differentially transferred with the circuit must solve with 1 to the sum of source frequency. This can be a long process, but only a good method to solve these circuits. Thievery and Norton circuits, Thievery and Norton circuits can be manipulated in similar to their DC counterparts on the phasor domain implementation Ohm's law, and voltage equal impedance times the amps. Important to remember that impedance does not change with the calculation, along with the phase of magnitude with both of the current and voltage source might be changed as a result of the calculation. Maximum power transfer in Ethereum phasor with a slightly different Ethereum DC. They obtain the maximum transfer with EVDM source to low with the internal EVDM impedance most complex. Conjugate the mid-load impedance. Complex power circuit theory and complex power. We're on that chapter.